Hello and welcome to tribetopper.com.
You're watching this video on important concepts of electrostatics for grade 12. In this video, we have a numerical for you which says that 4-point charges QA, that is 2 microcoulomb, QB, that is minus 5 microcoulomb, QC, which is minus 2 microcoulomb again, and QD, which is minus 5 microcoulomb, are located at the four corners of a square A, B, C, and D. We have to find what is the force on a charge of a 1 microcoulomb charge placed at the center of the square. So we first need to find the distance of this charge from all these other four given charges. So we know that the side of the square, it is given to be 10 centimeters. So we'll write this side here, 10 centimeter. Therefore, what should be the diagonal of the square? So we have two diagonals, AC, and the other diagonal is BD. So O is a point at the center where the charge of 1 microcoulomb is lying. We have to find out the force on this charge. So this distance AO would be half of the diagonal AC. Now, first of all, we write down that AB is equal to BC is equal to CD, and that is equal to DA. That's each side is equal to 10 centimeter. And now, what's the length AC? We know by Pythagoras theorem, this length AC would be square root of 10 square plus 10 square, as it gives the hypotenuse of the right angle triangle. So that's root 2 times 10, or 10 root 2 centimeter. Now that's my diagonal. Therefore, what is the half of the diagonal? That's AO. That would be 5 root 2 centimeter. So first we find out what's the forces. You know, this will be generally kind of a short question where you actually don't need any calculations. See, what is going to be the force on 1 microcoulomb due to the charge QA and QC? Both these charges are plus 2 microcoulomb and plus 2 microcoulomb. And the charge we have at the center is plus 1 microcoulomb. So 1 microcoulomb is going to experience a force of repulsion from the charge at A and the charge at B. And that is going to be equal and opposite. So force due to charge FA is going to be equal and opposite to the charge FB, because the magnitude is going to be the same but the directions are going to be opposite. So we would have a net effect that the resultant force on the charge at O is going to be 0. Similarly, the resultant force on this charge O due to the charges at B and C. Now we have the charges minus 5 microcoulomb both at B and D, and the charge at O is plus 1 microcoulomb, so it's going to experience an attractive force, but again equal and opposite. So the force on the charge at O due to C is going to be again equal and opposite to the force due to the charge at D. Therefore, we would say we can put a vector sign here because we're talking about the directions also. So that means FC plus FD would also add up to give you 0, which means the resultant force on the charge, right? The resultant force on 1 microcoulomb placed at the center O is equal to 0, because the forces due to the charge at A and C cancel out, and the forces on it due to the charge B and D also cancel out. So the resultant force is 0.
Please follow us on Instagram, Facebook, and Twitter at tribetopper.com.